Good morning, afternoon, or evening. How you doing today, guys? Messed up a little bit there on my intro, huh? Welcome back to Mr. Morrow's class, Algebra 1 and 2. Today we are going to wrap up 8.3, and I'm actually going to just continue on to 8.4 so we don't have any delays in recording. So this is where we left off, just some reminders, and then after this reminder, then we'll start applying some of the stuff that we learned. We're talking about functions, okay? So I think this is a great way to start the second half. Please remember that a function is a relation where there is only one y value for any given x value, okay? We talked about that, but really quickly. So for example, if I've got 1, 2, 3, and a 1, and I've got a 2 and a 4 and a 5, and then I got a 7 here, that is not a function because I have two different y values for the same x value of 1. If this was a function, then every single time that x was 1, y would have to be 2. Okay, that's how a function works. Please remember that the x values are known as the independent variable, it's the input, and it's the domain. Remember, independent, that means it doesn't depend on anything. When you go to McDonald's, you can buy 1 hamburger or 4 hamburgers, right? When I go to Home Depot, I can buy 1 bottle of Windex, or I could buy 4 bottles of Windexes, so I just have it so I don't have to go back to Home Depot for a while. When I go to the movies, I can be generous and say, you know what? I'm going to buy 4 tickets for my friends. Or I could just say, no, I'm just going to buy 1 ticket for me. Okay, so independent, you have a choice. Or I could go to the movies and buy 0, right? And there you go. I can choose to go to a restaurant, look at the menu and say, I don't want anything. I'm going to leave. Luckily, we live in that kind of a world, a free world. That's what independent is, it's choices. I can go into a restaurant and be really hungry. Maybe I was on a camping trip and I want to buy 3 steaks. I can. Okay? So, remember, x, independent, input, domain. Please remember that the y values are the dependent. They're the output and they're the range. They depend on x. The best way to explain this is with cost. Okay? If you're, at a restaurant, your cost depends on how many plates of food you bought. When I go to Home Depot, my cost depends on how many items I bought. Okay, so cost is a good way to really understand dependent. It depends on what you bought, how many you bought. It's also called the output because when you put an input into a function, your answer is the output, that's the answer, and it's the range. We already talked about range, and we know about domain and range. Please remember that functions represent a specific equation, okay, or specific equations that do not alter. That means they're not going to change on you. For example, I know I've used this a lot, but now I'm putting it in actual words. Movie tickets cost $12 per person. So a function can be written for that situation since it is constant. I think that's the adult price, so like 10 and above. If you're 10 or above, you're paying $12. It isn't, oh, Mr. Morrow, oh, you get the special super cool human discount of $9. No, Mr. Morrow pays $12 as well. So do all of us. You know, if you go to a movie theater that's only charging $7, great. Then everyone is charged $7 per ticket. That's a function. We call y the total cost. That's dependent. Since y is dependent, it is dependent on the number of tickets you purchase. We will call x independent, since you can buy as many tickets as you like. So the function is y equals 12x. And again, just to wrap this up and make it solid, every time that I buy 5 tickets, it's $60. No matter what day of the week, no matter what mood you're in, it doesn't matter if I bought it or you bought 5 tickets or a friend of yours or your girlfriend or your cousin or your uncle. Anybody that buys 5 tickets is going to pay $60. Anybody that buys 3 tickets is going to pay $36. Does not matter how many times they sell 3 tickets. Does that help just kind of solidify functions for you, my friends? Because this is really important, the concept. Does anyone have any question at all about this concept before we move on? Because it's really important that you get this. Okay, thank you guys. Now, let's see if we can learn how to create functions from both tables and word problems, word situations. If you remember what we just talked about, remember that the y depends on x, okay? So whenever I'm given a table, I always ask myself the following. I always say, what did I do to the x to get to this y? What did I do to the x to get to this y? So what's one option, guys, that we could have done? You could have multiplied it by -2. So let's try that out. Y equals -2x. Okay, it works when x is 1. Does it work when x is 2? No, because 2 times -2 is -4. So that's no good, but you know what? Now that you know that's gone. You don't have to worry about that now. What else could be done? Yes, sir. Okay, you could subtract 3 from x. Let's see if that works. When x is 1, it works. When x is 2, 2 minus 3 is -1. It works. When x is 3, it works. When x is 4, it works. Boom. That's my equation. For B, what's one possibility that I could have done to go from 1 on the x value to 3 on the y? Yes, sir. Okay, you nailed it right on the first try. You could have, a lot of people say add 2, and that's cool. But adding 2 isn't going to work, but multiplying by 3 definitely works. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 4 times 3 is 12. Boom. Beautiful. Okay? I give you easy ones, yes, because right now we're just learning. We're crawling. Little by little, though, you can get into more difficult kinds of functions, quadratics, cubics, but it takes time to build. The question always is, what did I do to that x to get to that y? Okay? What did I do to that x to get to that y? And now, do you guys remember that we dealt with linear functions already, right? You remember the point-slope form and the slope-intercept form and standard form and finding slope? Okay, well, one little trick I'm going to give you. Okay? If you see a table, since you guys have the skills to be able to write an equation that is linear, right now you're limited to linears. By the end of the year, you'll have quadratics, square roots, cubics, a lot. But right now, you have linears. Let's test to see if this is a linear equation. If you guys remember, you can test if it's linear if the change in y divided by the change in x is constant. So in other words, if the slope is constant, okay? This is all past stuff, so I'm going to go kind of fast. From 3 to 6, I added 3. From 6 to 9, I added 3. From 3 to 9, I added 3. From 1 to 2, I added 1. 2 to 3, I added 1. 3 to 4, I added 1. The change in y over the change in x is equal for all of them. Because 3 divided by 1 is 3. 3 divided by 1 is 3. 3 divided by 1 is 3. So I know it's linear. Now that I know that it's linear, okay, I can find my slope. And my slope equals y2 minus y1 over x2 minus x1, which is 3. Now I can do point slope form. Y minus y1 equals m times x minus x1. Solve for y. Y minus 3 equals 3x minus 3. Add the 3 to both sides. Y equals 3x. Now, I know what 99.9% of you watching and in class are thinking. Moro, that's really nice. Thank you. That's really awesome. Bro, that takes way too long. Yes, it takes way too long for a Mickey Mouse one like this. But what if the table I gave you a function that was y equals 2/3 x minus 5? Is it going to be that easy to find that one? So whenever you see a table, verify if it's linear. If it's linear, solve it, and that way you don't have to do guesswork. If it's not linear, then you got to guess and check. But at least we can eliminate any guessing with linear functions. We good there? All right. I think the tables are harder than the word problems. And in my opinion, the word problems are really easy. The gym you join costs $30 a month plus one-time fee of $250. So I want to write a function. Well, I'm going to say that my y is my cost, my cost, okay? And my x is the number of months. That's going to be my total cost, right? And I guess I should have put total cost and the number of months. So my total cost y equals $30 every month x plus the $250 that I had to pay to sign up. What's the point of this? Well, I can find out how much it's going to cost me in a year, isn't it? Because I can say 12 times 30, that's 360. 360 plus 250 is going to be $510. That's my real total cost for the gym. ABC cell phones charge $20 per month for unlimited usage of the phone. So it's just $20. They didn't have to put a down payment or anything. You sign a contract? Yes, sir. That's exactly, no, not y equals 20. Y equals 20x. It would be y equals 20 if I said ABC's phone charges $20 for the phone forever for all usage. That'd be a great deal. But no. Now remember, get in a habit of labeling. Y equals the total cost, and x equals the number of months. Now, none of this is really new, is it, guys? Because we did a lot of this when we were doing linears, didn't we? But remember, you're in Algebra 2. So part of Algebra 2 now is revisiting all of those things, making sure they're sharp so we can go forward, okay? May I continue? You have a question? Thank you. Okay, the question was on the quiz and test, if it's that simple, do we still have to label? Always label, man, because even the simplest of equations, if I don't know what the variables mean, it's kind of pointless. So thank you very much, but always label. Thank you, thank you, thank you. All right. Now, let's identify the independent and the dependent variables in each situation. That's all I want. Just want to see if you guys can identify the independent and the dependent. In the winter, more electricity is used when temperature goes down, and less is used when temperature goes up. What's independent? What's dependent? I saw your hand first, my brother. Very good. The dependent is the electricity used. Okay? It's going to go up depending on the temperature. Okay? So the temperature goes down, I got to really turn on that heater, my electricity goes up. If it warms up though, if it was negative 20 outside, but now it's nice and warm 52, I don't have to use as much electricity to warm my house. Very good. How about B? The cost of shipping a package is based on its weight. Yes, sir. I'll get you next, my man. Yes, sir. Very good. The cost is dependent. And what is it dependent on? The weight. Very good, son. Very good. The more it weighs, the more it costs. This may seem very simple, but these skills are super important. And I'm very proud of you if it seems super simple. This is what I want. The faster Mike walks, the quicker he gets home. This is a good one. The faster Mike walks, the quicker he gets home. My brother, who I promised. Yes, sir. No. Think about that. The speed he walks is dependent? That's okay. That's why we do this. Think about it. It says that the faster Mike walks, the quicker he gets home. What can he control here? Let's think about it that way. What can he can control how fast he's going, right? Very good. So his speed, Mike's speed is the independent, because He can choose to jog home, right? Or he can choose to just kind of chill and walk slowly. So what is dependent then? Very good. How quickly he gets home. How quickly he gets home. Actually, I don't like that. I guess, yeah, time it takes to get home. Thank you very much, boys, gentlemen. Time it takes to get home. Because, yeah, the faster he walks, the less time it takes. Maybe if he runs, he gets there in 5 minutes. But if he kind of just chills and walks, maybe it takes 20 minutes. Okay? A company charges $10 per hour to rent a jackhammer. A jackhammer is what they break up streets and stuff with. Yes, sir, my man. Excellent, sir. The dependent is the total cost for sure. I remember that'd be your Y, right? And independent is the number of hours for sure. If I rent it for 10 hours, it's going to be $10, right? Because the equation here will be 10x. 10 hours is going to be $100. Yes, sir. Absolutely. Last one. Apples cost 99 cents per pound. Okay. You got one of them right. The dependent is definitely the total cost. What's the independent though, my man? Aha, the number of pounds. Very good. Number of pounds, or I like the way you said that, the weight of the apples. I like that. Well done. Does that make sense, gentlemen? Any confusions or problems at all on this? Forget it. Remember, when in doubt, ask yourself, what can be controlled here? What can be controlled? What can I control? In this case, I can control how many pounds of apples I buy. I can buy 1 pound or 5 pounds. Anything that you can control, that's the independent. Works the same way for science fairs, guys. If you've ever done a science fair, don't you have an independent and a dependent variable? Right? And the independent is the one you can manipulate, the one you can change, the one you can control. Any questions on that, gentlemen? Excellent. May I continue? Thank you. Okay, now, here's the fun part. A function rule. A function rule, don't get scared. It's simply just an equation, guys, that represents an output value, which is y, in terms of an input value, which is x. You can write a function rule in what's called function notation. And this is going to be very important for you to understand. But it's going to take 2 seconds. Just memorize it. Shown below are examples of function rules. Okay, I gave you the same function rule. I started with the Mickey Mouse one, the Algebra 1 kind of function. Y equals 3x plus 2. Y is my output, and x is my input. So for example, if I say x is 7, 3 times 7 is 21 plus 2, y would equal 23. So y is dependent on my x input of 7. Does that make sense? Let us pause for 1 second, please. Right. Okay, guys, sorry about that. Thank you. So, really simple, okay? Now, this is just regular function. This is function notation. Notice how I have now, instead of a y, an f of x. My friends, I promise you, y is the same thing as f of x. Let me explain this f of x, though, because a lot of people get confused. This is read as f of x. What it means, it's function f of x, which is function f with independent variable x. You can have any combination of letters here. If you have, let's say, g of h, this means, okay, this is function g with independent variable h. The g here does nothing but name the function. That's function g. The independent variable is what's inside of the parentheses. So when you see f of x equals 4x plus 2, it's the same thing as saying y equals 4x plus 2. Now, you may be asking, if it's the same thing, Mr. Morrow, why are we learning it? Because they're going to give you situations like so. They want you to find f of 1. Basically, what they want you to do, f of 1 is the output, okay, the answer, when x equals 1. Remember that f of x equals y. So f of 1 in this case, in function f, when x equals 1, I replace the x with a 1. So f of 1 would equal 5. So my ordered pair, when x is 1, y is 5. Don't worry about the f. Some people try to solve for f. F is nothing. F is just the name. Sir, thank you. Yeah, now you won't get confused. Excellent, thank you. Yes, sir. Okay, thank you very much. The question was basically you solve for f? No. Wrong. Let me explain. Let's say I tell you y equals 2x plus 3, okay? In function notation, this is f of x equals 2x plus 3. When x is 3 here, y equals 6 plus 3, so y equals 9, right? So my ordered pair, when x is 3, y is 9. Does everyone see that part? If I do the same thing with function notation, I'm going to say f of 3 equals 2 times 3, because I replaced the x with a 3, plus 3. So f of 3, the value of function f, when x is 3 equals 9. My ordered pair, 3 comma 9. The f of x, it's not that you're solving for the f or the x. This is function f with independent variable x. F of x is one whole unit called y. So when I'm finding f of 3, I'm simply finding the y value when x is 3. Does that help you? Correct. What you have inside of the parentheses here, that's the independent variable. Hence, function f with independent variable x. Does that help? These are great questions. Does that make sense so far, guys? All right, let's see how it works. My function here is f of x equals negative 2x plus 5. Remember, this is the same thing as saying y equals negative 2x plus 5. So when I want to find f of negative 3, all it's saying is, hey, dude, what's the output, or in other words, what's the y, when x is replaced with a negative 3? Do you see that? So f of negative 3 is going to equal negative 2 times negative 3 plus 5, which is negative 1. So what's my ordered pair when x is negative 3? Y or f of x is negative 1. Yes? Wow. Maybe Mr. Morris should learn how to add. Negative to the negative is a positive. That's 6 plus 5 is 11. So, I was testing you guys. Good job. So, when x is negative 3, y is 11. Sorry. Thank you. Yes, sir.
So, now it's x. Like, x is negative 3. When you write it, it's actually negative 3 is y.
No, I never said that.
I know, but like, when you write
No.
Also, that's not like...
Okay. F of negative 3. I am saying this is function f, but I'm replacing the x with negative 3. When I do that, my answer is 11. So when x is negative 3, my function f of x is 11. It's the same thing as saying when my x is negative 3, my y is 11. F of x and y are the same thing. All I'm doing when I find f of negative 3 is I'm finding the y value when x equals negative 3. These are great questions. You with me here, my man? Everybody with me? Okay. Okay. Now, let's find f of 1/4. So again, what am I asking here? I'm finding the y value when x is 1/4. So f of 1/4 equals -2 times 1/4 plus 5. So that's -1/2 plus 5, which is 4 1/2. So when x is 1/4, my function f, okay, the y, f of x, equals 4 1/2. Because y is the same as f of x. But more, what's this f of 1/4? That's just function f, the value of function f when x equals 1/4. Are you guys with me? Let's find the value of f of 0. So I'm going to find the value of function f when x is 0. Or in other words, I'm going to find the value of y when x is 0. So -2 times 0, that's 0, plus 5, that is 5. So my ordered pair when x is 0, y is 5. Does that make sense? Now, if you've noticed, I'm plugging in, I'm replacing the x of the function with what I'm told. So in this case, I have f of x minus 1. Wait a second. What am I replacing my x with now this time? So this is going to equal -4 times x, which in this case is x minus 1 squared. See what I did? All I did was replace the x with what they told me to replace it with, plus 1. This hopefully you remember how to do. This is -4. X minus 1 times x minus 1 comes out as x squared minus 2x plus 1. Okay? Plus 1. Distribute the -4. That's -4x squared plus 8x minus 4 plus 1, so that's -3. And that is the value of function f when x is x minus 1. Sir? No, if you factor it back out, you'll go back out the other way. Don't worry about that. That's exactly what I want, my brother. Please and thank you. Yes, sir. You wouldn't write this as an ordered pair in this case. But if you wanted to, it's when x is x minus 1, y is -4x squared plus 8x minus 3. Technically, that's the ordered pair. Does that make sense, boys? Okay. How about this one? We'll do this one in blue so we can delineate the two. Okay. F of x plus f of -2. Well, f of x is straight up -4x squared plus 1 plus f of -2 is plus -4 times -2 squared plus 1. Do you see what I did here? F of x is just, I replaced x with x. So I had -4x squared plus 1. Plus f of -2, I replaced the x with a -2. So now I calculate. This is going to be -4x squared. And I've got -2 squared is 4. 4 times -4 is -16. -16 plus 2 is -14. Does that make sense, gentlemen? Go ahead. And then last but not least, f of 0 plus f of x plus 3. So f of 0, I replace the x in function f with a 0 squared plus 1 plus f of x plus 3. So plus -4 times x plus 3 squared. That's what I replace x with, plus 1. Yes, sir?
For the last,
Why wouldn't you combine what?
the,
You can't combine -4x squared and 8x. They're not like terms.
yeah, but the -4x plus 1's over there came like -4x and -4x. Like -4x squared and -4x squared.
Where is there 2 negative 4x squared, son? No, there are not 2 4x squareds. How do you figure?
Like the f of x is negative 4x squared.
This is f of x minus 1.
No, the second one.
The second one. F of x is 4x squared plus 1. And then it's f of negative 2. My x is replaced with a negative 2. Where are there 2 4x squareds? Do you see what your mistake is now, Bubba? You promise. Thank you. So now, 0 squared is 0 times negative 4 is 0 plus 1 is 1. And then I have here minus 4 times x plus 3 squared. It's x squared plus 6x plus 9 plus 1. So I've got 1 plus 1, so that's 2, minus 4x squared minus 24x minus 36. So that equals negative 4x squared minus 24x minus 34. If you wanted to factor a 2 out, you could, but the whole point of this is to be able to plug in and find the value. Does that make sense, gentlemen? So you're literally just plugging in the value that they tell you to plug in. Any questions on this at all, my brothers? Okay. I think there's maybe one more page. Yeah, okay. All right. Let's just do a general wrap-up now, okay? Tickets to a concert are available online for $35 each plus a handling fee of $250. The total cost of the function is a function of the number of tickets bought. What function rule models the cost of concert tickets? Evaluate the function for 4 tickets. Well, y is going to be my total cost. Okay. My x is the number of tickets that I buy. And my function y equals $35 each ticket plus $250. Or I could write it in function notation. F of x equals 35x plus 250. And if I want to find the function value when x is 4, y equals 35 times 4 plus 250. So y would equal 142.50. Or I could say, okay, I want to find the value of f of 4. And all f of 4 means is, what's my y value, what's my output when x is 4? And it's going to be exactly the same answer. Does that make sense, guys? Yes? Okay. You are buying bottles of a sports drink for a softball team. Each bottle costs $1.19. What function rule models the total cost of the purchase? Evaluate the function for 15 bottles. Y is going to be the total cost here. And X is going to be the number of bottles that you buy. So the total cost Y equals $1.19 per bottle X. Done. Done, done, done. Now, when I want to evaluate, just for time purposes, I'm going to cheat. Use a calculator. Y equals $1.19 times 15 bottles. So we're talking about, thank you, $17.85. Please remember, you could have written f of x, which is the same thing as y, equals $1.19 times x every bottle. What is the value of f of 15? All that means is, what's my y value when x is 15? And you're going to have the same exact answer. Do you guys see how this is paralleling? You catching that? How it's the same thing? Don't make a mountain out of a molehill. Okay, now, in 2002, Prestige oil tanker sank and started leaking oil off the coast of Spain. The oil slick took the shape of a circle. Suppose that the area A in square miles of the circle contaminated with oil can be determined by using this function. Please don't stress out. All this means is this is function A with independent variable T. Excellent. Where T represents the number of days since the tanker sprang the leak. Identify the dependent and independent variables. So the dependent is my A of T. Because remember, my A of T is like the f of x. That's the dependent variable. That represents y. My independent is T, which is time. The number of days. So evaluate A of 30. All this means is, what is the output or what is the dependent value of function A when T is 30 days? So this would be 0.25 times pi times, if you're doing it in a calculator, do parentheses 30 squared, and your answer will be, oh boy, that's so sad, 706. I'm rounding 0.86 square miles. Yes, sir. Yes, you can multiply by the symbol pi. That's going to be the most accurate. That's most accurate because it takes all the decimal places into account. Does that make sense, guys? Pretty simple, no? Okay, we're good. All right, let's see what we can do here. Let's see what I can do with 8-4. These things have been taking me longer than I wanted, but it is what it is because I need you guys to really understand and know this. Okay. This, I may be able to knock it out. We'll see. A lot of this is just reminders. Remember, we just finished seeing this. That f of x equals y. And that f of x is interpreted as follows. Function f, where x is the independent variable. In order to find the domain of a function, when only given equations, you must find all the real number x values that make f of x a real number. It is very easy to find the domain of a function when only given an equation. If you remember that the domain of any function will always be all real numbers except three categories. Okay? So it's always going to be all real numbers, except for three categories. Whenever x, or the independent variable of that particular function, appears in the denominator, you must set that denominator to not equal to 0. The domain will equal all real numbers except for the values that make the function undefined. The point here is I cannot have 0 as a denominator. So if I want to find the function of a, I say, oh wow, wait a second, there's an x in the denominator. So I got to set the denominator not equal to 0. So what is my domain? It's every single number in the universe except for 0. How do you write that, Morrow? It goes from negative infinity to 0 with the parentheses, not a bracket, because 0 is not included, in union with from 0 to positive infinity. So anything from negative infinity to 0, that works. And anything from 0 to positive infinity, that works. But what's the one that doesn't work? 0. That's why it's in parentheses. If it did equal 0, it would be in brackets. Does that make sense? Yes, sir. U means union. It's in union with both. It's this in union with that. You have to. Yeah, there's no choice. For B, I have an x minus 5 in the denominator. So let's take that x minus 5 and set it not equal to 0. So x cannot equal 5. Any other value in the world, in the universe, can work. So from negative infinity to 5, I'm cool. In union with from 5 to positive infinity, I'm cool. But what's the one that I cannot use? 5. We'll continue this tomorrow, guys. Thank you. Have a great day. Hope we learned a lot.